Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we dive into the world of optical design, learning about the design challenges and complexities of optical systems, as well as some of the instruments used in optical labs. Jacob Wimmer is a seasoned optical engineer with a lifelong affinity for lighting. Jacob's journey into the world of optical design began at a young age, spending his summers immersed in his father's optical design business, Charlevoix Design. Little did he know then, those early experiences would shape the trajectory of his career. After studying architecture at the University of Michigan, Jason drew upon his lighting background to land a position with an architectural lighting design firm in New York City. But the call of home beckoned, and Jacob returned to northern Michigan, where he now co-manages Charlevoix Design alongside his father, Chris. Beyond his professional pursuits, Jacob finds solace in the great outdoors, where he shares adventures with his wife and two young daughters. An avid hiker, he's tackled over half the Appalachian Trail. He also enjoys bow hunting for white-tailed deer in Michigan and hunting for elk when he can make it out to the western states. Charlevoix Design thrives on diversity, servicing clients across various industries, from illuminated logos to automotive headlights. In our conversation today, we uncover how Jacob collaborates with clients to overcome challenges in material definition, system integration, and we hear about Jacob's experience revolutionizing snowblower lighting. Join us as we dive into the illuminating world of optical design. Let's get into it. Hey, Jacob, welcome to the show.
Hi, Troy. Thanks for having me.
Sure. So I started Impulse over 25 years ago, worked for a company that had like all facets of product development under one roof, saw that they were not in it for the long haul, and we kind of started Impulse to help companies design products and get them developed and manufactured. So how did your company get started?
Sure. So actually, we're a family company. My father started Charlevoix Design in the mid 1980s. He'd worked for a few other larger companies doing optical design work for automotive, both exterior and interior, and then another company doing injection molding of lenses and reflectors, vacuum metallizing of reflectors for street lighting and more general type applications like architectural fixtures, things like that. And so he eventually just wanted to go out on his own and return to his hometown in northern Michigan. And so he started his own optical design service.
Very interesting. So obviously you provide optical design services. Walk us through what that entails a little bit. Like, typically the question is, what services do you provide? So kind of expand on optical design and what that means.
Sure. So our kind of slogan is we provide full service optical design, kind of an informal slogan, but what we mean by that is we're here to kind of assist our customers from early stages of product development, from initial concepts. We can help them develop concepts and do feasibility studies, and then we're going to help them progress through the design and take it to final production, in which case we can be there to help measure. We've got a photo lab and can help measure parts. And then kind of some of the main services that fall under or kind of occur during the entire process. Excuse me. So optical design, when we say optical design, we're talking about 3D, defining in 3D CAD lenses, reflectors, light pipes, light guides, and other optical components.
Okay.
So, one of our big deliverables is we're going to give you 3D CAD data that says, this is what your reflector needs to be. And then you're going to take that, incorporate it into a mechanical design. And then actually, very importantly, we always ask for, once our surface data is incorporated, we want it back to do a final check simulation. And I'll explain simulation in a second.
Okay.
And so that's kind of the big thing. And then along the way, we're generating reports and providing status updates on this is our prediction for the actual photometric output, what the light is going to do in your product. And so along with that goes optical simulation. That's virtually always a part of optical design. I say virtually, it is always a part of it. So when I say optical simulation, we're talking forward ray tracing. So there are, like most like for instance, LED manufacturers will characterize their sources. So each LED gets characterized, gets measured, and they generate ray files. These are very precise sets of data that tell you where light is coming from and where it's going.
Hmm.
And it's very helpful to have these accurate measured files. And we can download these from LED manufacturers websites, put them in our software, and then we can start building optical systems in 3D and assigning them materials. um, eh, I mean, basically, we're just loading in components and assigning them appropriate materials, and then we're running a simulation, in which case sensors that we set up will detect how the light moves through the system and give us an output that we can understand, and understand it against whatever the target specification is.
Okay. And when you say material, is that like it's not the light material, it's the material that it's reflecting off of?
Right. So, for instance, a reflector, we're typically talking about vacuum metallized plastic components.
Okay.
So, there's that's just how reflectors are often manufactured.
Hmm.
Aluminum vapor is deposited on a plastic component, and for instance, we'll say, just based on our experience, we would say we're going to run 85% specular reflectivity. Specular
Okay.
meaning, it's like a mirror, um,
Okay.
as opposed to a very diffuse type of reflection. And
Okay.
85% of the light that hits that surface is going to be reflected.
Okay. All right. So when you say optical design or that you guys design lighting, you're actually not designing the lights, you're designing the reflector. But
We are designing the reflectors, the lenses, those types of things. So typically we're working with electrical engineers and mechanical designers and other people that are developing how a product comes together.
okay.
Example might be a flashlight. So we've done flashlights, or headlights, talking about the things that go on your head.
Hmm.
um, and so there's definitely another team of people, but we are kind of the experts when it comes to, um, here's how, if you have, I mean, first of all, we can help you understand, if you're somebody that says, I want to develop a flashlight, but I don't know, what's a good flashlight, what's an appropriate beam pattern,
Hmm.
what's a lumen,
Right.
or what's candela, I want to be able to see a certain distance. So we can help you say, okay, well, if you want to see a certain distance, and we can even test other products on the market in our photo lab and show you what they do, and then we can help kind of quantify, um, or build an objective system of measuring, um, that light and that outcome, so that we can build and simulate something that's going to meet the desired outcome.
Okay. Yeah. You mentioned the photo lab. Um, what are you actually measuring? Are you actually measuring like the light output or yeah, explain that?
Yeah, that's a good question. That actually gets into kind of the next service that can be a standalone service as well. So we have a variety of different instruments. One of the things we have is it's called a Type A goniometer. And
Okay.
what it is it's a really large piece of equipment. I don't know, it's probably 10 feet wide, 7 foot tall, and there's two axes. There's
Okay.
two servo motors, and you mount something like an automotive headlamp or a tail lamp in the center of it.
Mm. Okay.
And based on those servo motors, you can turn that lamp in any direction. 100
Okay.
feet away from that lamp is a photocell that's measuring intensity. It's measuring light coming off of that lamp, that only the intensity in a single direction. So
Okay.
if you're talking about 0 degrees horizontal, 0 degrees vertical, basically straight out from the lamp, you'll measure just a small area because you're 100 feet away. So, but
Yes.
then we can rotate, 5 degrees right and measure what's coming off that way. So that's a really helpful piece of equipment to have. Um, Very few people have a facility with 100-foot test tunnel unless you're
Right.
manufacturing these kind of lamps, and it's often used for automotive, but it's very helpful in other applications as well. So that's kind of the big piece of equipment, and then we have a small integrating sphere, which if we can use this to measure lumens coming out of an LED. So
Okay.
oftentimes people, will measure a part and people say, well, it's not bright enough. It's not meeting specification. Well, let's dismantle it and let's actually measure the LED lumens off
Hmm.
of, your off of your LED and see if that's matching the simulation assumptions. And
Right.
oftentimes we'll find out that it's being underdriven or whatever. So we can also measure color temperature. We can measure the color of LEDs, which is defined in something called the CIE color space. There's depending on what you're doing in lighting, that can be very critical. And we can also measure luminance. We have a luminance camera, which is it's like um, it's a way of measuring perceived brightness. So, and the unit is candela per meter squared. Um, and so it's like a gun. It's like aiming a scope at something like maybe it's a lit logo, and you want to understand how bright is this thing relative to any other brightness, and so that luminance meter will tell you.
Okay. Very interesting. Um, oh wow, I had a question and I just lost it. Uh, Earlier you talked about 85% reflectivity. Is that right?
Yes,
Is that kind of the max, or if not, why don't you go to 100 and like
sure.
explain that a little
So, and that was just kind of an example
bit?
of a definition that we would actually apply to a surface. Um, there can be variance. I mean, that's just kind of a very typical reflectivity that we see using vacuum metallizing, which is very efficient. Now, there's other coatings and things like that that can be applied that can increase reflectivity. And so sometimes our customers that are very intimately familiar with these things will, they'll actually specify, well, actually, we're going to use 87% reflectivity,
Okay.
or it very very rarely goes higher. But it is critical to know these things because we've, I I mean, we've had situations where maybe it's an unknown and then somebody comes back and makes a part, a prototype, or even a final part, and um, it's a chrome part, and they assume that chrome is going to be as reflective as vacuum metallization. And I'm going to kind of throw a number out, but I think it's around 50% reflective instead of
Oh,
85, and
okay.
massive difference.
Sure. That's interesting. Um, you were talking about the measurement tool that's got the 10 foot by 7 foot and then the 100 foot run. What was that
Hmm.
called again?
Goniometer.
Okay. So when you're measuring that, is it you're only measuring like one direction, or does it kind of give you a, for lack of a better term, like a spectrum of like in the middle the light is shining at this intensity and out here it's at this intensity? Kind of gives you a map, so to speak, of what the light's doing.
Yeah, so it's only going to measure one moment in time, but
Okay.
like I referred to, there's two axes, two servo motors. So we can program it to to scan an area. Like let's say you want to understand, let's say it's a flashlight, and
Hmm.
you know that your beam pattern is within plus or minus 30 degrees horizontal and plus or minus 30 degrees vertical. We can do a scan and we can take a measurement every, for instance, quarter of a degree. And so we'll get this data back, and we're going to have a measurement every quarter degree in two directions. And what we can do with this data in our software is really cool. We can actually take this data and generate what's called an IES file, which is, I mean, it's basically a file that contains this data, but there's software that can project this data onto a surface. So we can take measured data and simulate with it. So if you wanted to understand, we've measured in candela in intensity, but we want to understand what's going to fall on a ground plane, which would the measurement would be in lux or lumens per meter squared. So we can take this measured data and project it and accurately get what you would expect on your target plane in
Very,
simulation software.
very interesting. So Impulse works with like inventors, individuals, small design teams, medium, large design teams. What's your typical client look like?
Sure. And so I guess we don't. I wouldn't say we have a typical client necessarily, but I mean, our kind of bread and butter is automotive, both exterior and interior.
Okay.
And on one side of the spectrum, there's customers that um, they're very experienced, very uh, large companies that might manufacture, say, a tail lamp for a vehicle, and they may have a team of 10, 20, or more optical engineers, but perhaps at a moment in time they're just too busy and they need to outsource some of their optics. So we're kind of we serve as that buffer
Hmm.
at times. That's one scenario, but then we also work with, I'd say, small to large companies that are, maybe they're developing their first lighting product.
Okay.
Maybe they're, we've worked with agricultural company, or actually better um, example would be like lawn and garden. So
Nice.
somebody that is developing a lawn and garden product, or that's what they do, but they want to incorporate a light into their product for the first time,
Yeah.
or they want to greatly improve the lighting that exists on their product. So that's a customer that's like less well versed in lighting usually, and so there's more kind of education that needs to happen, and more conversation, which we love and encourage. So
Yeah.
um, yeah.
Yeah. That's cool. So what is it about the way you guys do business that attracts your clients to come back again and again and again?
Yeah. So you know I I started. I mean, I actually worked in high school during summers at Charlevoix Design, measuring in our photo lab,
Hmm.
and I continued to work summers through college. And I had the opportunity to attend a users group meeting for our primary software. It's very specialized software, and I go into this room of people, and there's probably 20 people or so. It's not huge, and everybody's got a name tag that says where they're from, and I knew no one. But
Hmm.
we're a small company in northern Michigan, and I had multiple people come up to me afterwards and say, "Oh, you're." They recognize the Charlevoix Design, and they recognize my last name from working with my father. And
Hmm.
I had people that say, "Oh, your dad really." We've worked with him a long time. He's helped us out of these tough spots. We really enjoyed working with him, and I mean that made an impression on me, right?
Sure.
And I think what we try to do is, I mean, of course we try to be experts, and we have, it's getting close to 40 years that Charlevoix Design has been around.
Yeah.
Um, so we have a lot of experience, and we just really try to emphasize this service people,
Yeah.
and do what we can to help people in whatever their goals are.
Sure. Sure. Um, so I always like this question because everybody sees the product development world kind of from a different angle.
Hmm.
You've got your niche, obviously. So, what do you see as the biggest challenges facing product development professionals?
Yeah, I mean, I think this depends on the customer quite a bit. I know in the automotive world, and probably other industries as well, everybody wants very, very quick turnaround, and they want a very high quality of service at a quick turnaround.
Mhm.
Um, so that's one challenge. And we couldn't do what we do without software that greatly speeds up the process. And then for those that are new to lighting, it's, which is, we have a decent amount of customers that are new to lighting and they don't know where to start.
Mhm.
And so then how do you, one of our objectives becomes to kind of coach these people through. And we need to ask questions and understand, okay, well, what are your goals for this product? Let's say you have a product that you want some kind of indicator light, but it needs to be, you want it to look like something more than just this tiny little glowing speck. You want it to be a lit emblem. Let's say
Mhm.
your logo lights up. So how do we define how bright it is? Like what environment are we going to view it in? Is it going to be under sunlight, or is it in a dark room? And what kind of luminance value should it have? And then how do we go from, okay, we have now defined an objective outcome to, where do we start with LED lumens, and so, we kind of need to walk people through that process, which is usually all part of a early stage concept and feasibility study.
Hmm. That's interesting. Um, so can you give us like I guess a success story, kind of an example of, somebody used your service and I don't know, you overcame a big challenge or, something where you helped achieve a successful outcome.
Sure. And I mean, there's a variety of things that come to mind. I mean, certainly automotive lamps are some of the more complex, automotive exterior lamps are some of the more complex ones. But
Mhm.
oftentimes, like, I walk away, from a project feeling good if we were able to kind of overcome a big, I mean, timing is always a huge issue there. So if we can
Sure.
do a good job with that, I appreciate those projects. But I think some of the more interesting ones to talk about are, or at least for me, um, we had the opportunity and we'd wanted this opportunity for a long time. We live in northern Michigan. We snow blow, right? We're clearing snow in the winter,
Mhm.
and we're oftentimes doing that in the dark. And I have a, won't say the name of it, but a big orange snowblower that does a great job, but its light is kind of abysmal.
Oh,
It's a, it's got a bulb. It's got an incandescent bulb and a reflector. I'll say reflector with air quotes because it doesn't focus the light. It's not
okay.
designed. There was no optical design to it, and so I end up wearing a headlamp, a light on my head. Um, and we were approached by a different company, to develop two snowblower lights. And it really is a pretty simple design, but what was neat about it was, we brought TIR, or total internal reflection type optics. It's a lens, basically a clear material, that uses internal reflection and refraction to collect. They're extremely efficient optics, and there's
Mhm.
different ways of there's different configurations for them. But we did something where we focused the light vertically, which helped get a really nice hot spot. But then we allowed the light to more naturally spread horizontally, so you could see kind of 180 degrees
Mhm.
around the snowblower, in front of you. So very controlled vertically, but spread out horizontally. And like I said, fairly simple design for us, but at the end of the day, I mean, customer came back with the before and after pictures, just their old product and their new product and their facility. I mean, it was literally night and day. I mean, it was like,
Sure.
wow, this is the light I want to be using at 5 a.m. in the morning when I'm clearing
Right.
snow.
Yeah.
Another quick example is, both my father and I are runners, and we had somebody come. They wanted us to do a light that you wore on your head that was specifically kind of marketed towards runners, and we got to
Mhm.
go. We kind of went above and beyond, put some extra time into it. Um, we did some product testing. We tested things in our lab, but then we also went for runs. We would go outside and run down a path, and kind of talk to each other about what we liked, didn't like about lights and
Mhm.
different lights. And then we actually polled some other runners, and we ended up coming up with a fairly unique pattern that put a we focused most of the light in a very tight beam, so you could see far. But then we
Mhm.
also had a kind of a near field light, that we drove down a little bit more, so you could see better right in front of you, which gave you this overall sense of security. And you need to have the right kind of proportion of light downrange to light in front of you, so you don't, if you have too much light in front of you, you don't feel like you can see as far. So
Yeah.
that was another instance where I think that was had a really good outcome and was kind of near and dear to our hearts.
Yeah. Yeah. That's really interesting. So when you talked about, I didn't realize you could do this. You talked about, sending the beam far and then sending one down. Is that all one light? And then the reflector's just designed to do that?
Yes, it's all one light. That one is actually a TIR design as well. So again, it's one molded plastic component,
Mhm.
acrylic, clear acrylic, and we're shaping. I mean, there's different ways of doing it, but we're shaping the reflective and refractive surfaces to I mean, really, you're shaping them to create a beam pattern, the beam pattern you want. And I mean, a lot of times what we'll end up doing is if we're working with something that we know is going to be tight, a tight beam pattern, but then we want some degree of controller spread, we'll collimate the light at first. So we'll focus as much light as we can into a very tight beam pattern, and then we'll add some kind of optics, like pillow optics, they're called on the A side, that spread, that take this light that's coming out more or less parallel,
Hmm.
and then they're adding spread. Maybe you want 25 plus or minus 25 degrees spread horizontal, but only 5 degrees vertical. So we can kind of define different surfaces to do that.
Very interesting. So you're designing, I'm picking up now, you're designing the reflector to do one thing, and then the lens does another thing.
That is often a tactic, yeah.
Interesting. Very, very cool. I wanted to go back to the snowblower example. Did Orange Snowblower Company get a better light after they saw the other company's light?
So I haven't had a chance to test it, but they have. They do have
No.
actually, I think, a pretty similar light now. Although I've seen it in the local big box stores, and I've wondered about the optical clarity of the material they're using. So I'd be really curious to test it myself.
Yeah. Yeah. Cool. So at Impulse, we do everything we can to make it super simple for somebody to start working with us. What's the process look like for somebody to start working with Charlevoix?
Yeah, I mean, the process, I mean, it always starts with a conversation, and the best way to start that is go to our website, charlevoixdesign.com, and we have a contact form you can fill out, and we will get back to you very
Okay.
quickly.
Cool. And then after that conversation, the initial conversation, is it just quote PO go or is there any other stuff that has to happen before that?
Yeah, so I mean, usually we'll, do some kind of introduction conversation, and then, usually we're going to ask that you share 3D CAD,
Hmm.
share any specifications you have, whether that's, hey, we have a really good idea of, the type of, you know, uh, beam pattern we need to create, or, it's a, uh, I keep using the lit logo example, but hey, it's a lit logo, and we need it to be X candela per meter squared. So sometimes those things are very well defined up front. Sometimes they're not. Color, there might be color specifications. And then, if LEDs are already selected, which oftentimes they are, but we can certainly help select LEDs as well. And then some kind of BOM bill of materials, so we understand what all the components are and how we can define them in our simulation software. So once we'll collect as much information as we can and provide a quote.
Yeah, interesting. I've been meaning to ask this question the whole time because you keep mentioning LEDs. Is it pretty much 100% LEDs now, or do you still do some incandescent stuff?
um you know it I want to say it is, but I think it was maybe a year, nah, maybe a little longer. No, I was working on a tail light. I mean, if you see um, many different cars on the road today, there's, like, let's say it's a truck, there might be a base level version with all halogen and incandescent bulbs, and then there's the high level version that's all LED.
Hmm.
um, and so I've worked on a base level tail lamp not too long ago that used all incandescent.
Okay, yeah. I drive old cars, so are all the lights LED now, or are they still halogen sometimes?
Oh, they're still halogen. I mean,
Okay.
I'm driving what to me is a pretty new vehicle, and it's 4 years old, and
Mhm.
I've got halogen headlamps.
Interesting. Um, so what's the biggest challenge your business has seen over the years?
Um, I guess we've seen, like I said, our bread and butter is automotive,
Hmm.
and for exterior automotive especially, I mean, the the players out there, the manufacturers of headlights and taillights and other products used to they they're having more and more, they have larger teams of people that are working on them. So
Hmm.
they might have, 20 optical engineers or 10 optical engineers, as opposed to, it used to be they had a handful, two, three, four, five. And I mean, there's a lot of demand out there for this type of work, but as some of our big customers have gotten bigger and grown their own resources, they're less and less likely to need to outsource
Sure.
this. And then on top of that, there's definitely there are competitors that are overseas, and
No. Sure.
as you can expect, they're probably going to be cheaper.
Yeah. Yeah. We see that that too. That thankfully there's the time difference, the cultural difference, the language
Yep.
difference. That seems to be still more efficient to use us, even though yeah we're more expensive than some of the services you can get overseas. So
Absolutely. I mean, that certainly helps out us out, and then just the experience we have. I mean,
right.
the 40 years of experience helps.
Yeah. Yeah. Speaking of experience, and maybe we should ask your dad, but what's the biggest change that's happened over the life of the business?
Oh man, that biggest changes over the life of the business. I mean, I know he talks a lot about industry changes that I really haven't seen. I mean, LEDs have been huge,
Sure.
obviously, and then with that, I think people are incorporating some kind of lighting into products more and more and more. I mean, even just look at automotive as an example, and if you look at newer vehicles, I mean, usually higher end vehicles, but um, now not always. There's all kinds of things that light up in cars now,
Yeah.
um, and it's just, I mean, it is good for our business. Um, and then
Yeah.
consumer goods too, that people want to incorporate lighting more and more often.
Sure. Yeah. When you were talking about headlight and taillight designs, it seems like, I don't know, but it just seems like they've become so much more complex than, you know, 20, 40 years ago.
Oh, absolutely. And something that goes hand in hand with that is iterations. So, one of the great things about what we can do is, I mean, the software we use is highly specialized. It is very accurate.
Hmm.
If you put the right, if you build it the right way,
Hmm.
do the right things, it can be extremely accurate. Um, and it's also you can do things very quickly. The but it used to be, there was, when you were given a tail lamp, let's say, everything was kind of defined, and you were only expected to go through, one or two iterations. And now it's, we're looking for perfect homogeneous lit appearance, um, and balancing costs, and it needs to be absolutely perfect. I mean, we got to get the look right. We got to optimize wherever we can, and
Hmm.
that's good. But actually, in addition to that, there's just design changes. There's constant changes that happen throughout some of these, product development life cycles,
Sure.
and so we'll just iterate and iterate and iterate and iterate. We're just always being asked to do that, and so we're constantly on our feet and um, looking. I mean, just constant changes.
Sure. Yeah, that's interesting. So, um, kind of as we start to wrap up and shift gears just a little bit, but what are some of and you kind of touched on this, but what are some of the emerging trends you're kind of seeing in your corner of the product development world?
Sure. So one of the big things is homogeneous lit appearance. I mean, when you and you can see this in automotive, and you can see it in other products, but when LEDs first came on the scene, you noticed it. You could kind of see the individual LEDs, but now people want to see. An industrial designer will say, "Okay, I want a certain shape. It's a C shape or whatever. It's or just a line of light. I don't want to see the fact that there's individual LEDs."
Right.
And that can I mean, that has its own challenges with it for sure, because you now have to diffuse the light to hide the fact that there's LEDs, and there's so many different ways of doing it. But one of the common ways, especially for more like consumer goods or interior automotive, is translucent materials.
Mhm.
And translucent materials are um, it's gotten better and better, but it's been hard to come by accurate definitions that we can use in simulation software, because you have to you basically have to measure how light scatters through that material, and you have to understand how light is also absorbed through the material, so you can understand, okay, if I have a 10-degree beam going in, depending on the thickness of the material, it could be a 20-degree, 30-degree, 60-degree beam coming out,
Okay.
and 50% of the light is going through, or 80% of the light is going through, or 20% of the light is going through. um, so that's been a challenge, but it's gotten better. Our access to material definitions has definitely improved in recent years.
Yeah, interesting. You mentioned homogeneous
Lit
what was it?
appearance.
Lit appearance. So that's
Yep.
basically you want the entire lens or light or whatever to look the same.
Yeah, to something needs to glow evenly, so
Yeah.
it
Okay.
doesn't look like there's hot spots and dark spots in it, that are kind of off-putting to the eye, I suppose.
Yeah. Yeah. In your experience, what are some of the most underutilized tools that you guys offer?
Oh, underutilized tools. Yeah, I think I would think about that in terms of a service, that anyone looking to jump into lighting for the first time should consider, and that is, um, we'd really like you to engage us early on in a project and consider doing a concept and feasibility study.
Okay.
Um, you know, you'll learn a lot going through a feasibility study. It's extremely helpful if you're new to lighting. Um, and so oftentimes we get engaged later on when there's already a space claim for this optical system without it really having been understood, and there's already a bomb, and and somebody they know exactly what they want from a light output standpoint, but they've kind of defined some parts and pieces to get them there, but not well enough. And now they've designed enough of the product that it's in a space where you can't possibly um, get what they're looking for.
Yeah.
And I mean, if you engage us early on, there's really very quick studies we can do. I mean, sometimes it's a couple days, sometimes it's only a day or less to figure out, or and just have a conversation. I mean, sometimes we'll just know, hey, this is not going to work, and it's not going to work because of physics,
Right.
and we can help show you that. So the earlier you can engage us, the better.
Yeah. Yeah. So in the feasibility study, you're not just saying this won't work. You're also saying to accomplish what you want to accomplish, we need this much space or this much depth or whatever it might be.
Right. I mean, a lot of times we can help guide people early on, and honestly, there's times where we'll get through a concept study, a feasibility stage, and if it's a simple part, sometimes 50 to 80% of the work is already done.
Hmm.
So maybe you only need a couple more days and a final check simulation to finish the process.
Interesting. So I don't know if this question will apply, but I'll be interested. How do you see the role of AI impacting the development process in your world?
Yeah, I'm not sure. There's, I mean, I don't see it having like currently, I don't see anything out there that's going to have significant impact, but that could change quickly.
Sure.
There are optimization tools that are built into some of the software packages that optical engineers use, illumination optical engineers, that are there to help you try to get to a good result without um, having to do much of your own legwork.
Mhm.
And I honestly am not super experienced with them, but from what I've seen, oftentimes, they're just guessing and they're changing variables that you have to set up anyway,
Right.
and you're better off just using experience to define a system up front and go through a couple iteration, and somebody experienced at this is going to generally be able to get to a better result just as quicker.
Yeah. Yeah. So last question. Anything else you want to mention or talk about before we wrap up?
Sure. Uh, you know the optics are very sensitive. I mean, what we do, it's not rocket science, but it is, um, you know it can be, these systems can be very sensitive, and more than what some people in product development are used to. Like, we talk in terms of LED positional tolerance of plus or minus a half a millimeter in every direction, and
Mhm.
that's pretty tight to some people, and in certain applications we've got to be tighter than that. That's not to say every application requires that kind of tolerance, but some do. And when I mentioned um, needing an appropriate space to work within, and the larger an optical system is, the more forgiving it is. It's just a product of focal distance,
Okay.
um, and so it, there's um, I mean, like I said, these systems can be very sensitive. And so I would suggest to people that are looking to develop these, try to understand the system and don't make assumptions. Um, when I say that, there's other variables. There's mounting features. If you're talking about mounting features on a light pipe, they can just sap light out of a system, um, and create light leaks and hot spots that, if we don't account for those in simulation, which we can, um, there's going to be issues. So we try to circumvent those things. We try to understand as much of the design as we can up front, and we'll account for that in simulation. But there's just instances where things change later on,
Hmm.
and you need to keep your optical engineer up to date with those. So I mean, we even see people change out LEDs, and that they don't tell you right away. Well, it can
Yeah.
be a huge difference. Um,
Sure.
so just be aware in working with optical illumination systems that any small change, material changes, they all make a difference. So just be aware of that and make sure you're having open conversations with your optical engineer and keeping them abreast of everything that's going on. And do check traces. You know what Before final parts go out for tooling, like, deliver that CAD to your optical engineer, have them do a final check trace, because uh, almost always you'll find something. There are
Mhm.
small changes, and you'll find something, and it's
Yeah.
better to know about them up front.
Sure. So this has been great. Where can we learn more about your company?
CharlevoixDesign.com.
Okay.
Um, and that's a little bit of a hard spelling. It's CHARLEVOIX, design, all one word.com. Like I said, just reach out to us via contact submission, and we'll respond
Cool.
quickly.
Awesome. Yeah, I'll get that in the show notes, and they can just click on the link down below and won't even have to spell it.
Yep, or reach out to me on LinkedIn. It's another
Okay.
good way.
All right. Awesome. This has been great. I really appreciate you doing this, Jacob.
Yeah, thank you, Troy. It's been fun.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.